Okay, so we were calculating the moment at the fixity to make sure it should be 11. Okay, so to find sum of moments about B, sum of moments about B using the clockwise direction as positive, what do we have? We have first plus MB minus uh, the moment of the distributed load is counterclockwise, so it's minus 1.5 times 2, which is the force, because I replaced the distributed load by a force, and it should pass by which point? By the centroid. Okay, so this is my force replacing the distributed load. It's equal to 3, and it's located at 1 meter from B, because it should pass by the centroid. So this distance is 1. So I should multiply 3 by 1. So it's minus 1.5 times 2 times 1. And now for the 2 kilonewton force, it's also producing a negative moment in the counterclockwise direction. So it's minus 2 times the distance. What is the distance to B? It's 4. So times 4. So I get equal to 0. So I get that MB is equal to plus 3 plus 8 is equal to plus 11. In this way, I verified my results. Okay, so always the reactions at the end can help you to verify if you did a calculation error in your problem or not. Any question on this? Okay, so let us continue. Let's do another okay. We give the following beam, and we want to draw for this beam the bending and the shear and bending diagram. So first, what do you have here? If you look at your beam, at A, this is the figure of what? This is a pin, and at B you have a wheel. This is a roller. So these informations you should know them from the previous chapter, which is included for the exam. Okay. So first, I can start by saying that I will represent my reactions. I have a pin here, so I have a X and a Y. Okay. Look here. Who can tell me how I can predict that a Y will be down and not up? Who will tell me why a Y will be should be downward and not upward? Look, you have equilibrium, yes or not? If you take point B, the moment about B should be 0, yes? But your distributed load is doing a moment in which direction about B? It's doing a moment about B in the clockwise direction. So, and the only other force doing a moment about B is AY, because AX is passing by B, and already AX is 0 because you don't have any other force in F. So the only force that can oppose the moment of the distributed load is AY. And since AY should produce a counterclockwise moment about B, then it should be downward. Because if it was upward, it will also produce a clockwise moment about B, and we don't have equilibrium. If you didn't pay attention for this, it's not a problem. You can put AY up, and when you do the calculation, you will get that it is negative. Okay? So now, since I paid attention for this, I will put AY down, and I will put BY up. And in this problem, you should start by calculation of reactions. It's not like the previous problem, because in the previous problem, the reaction was at the end, so we can just use it as a verification. However, here, we cannot start without knowing the reactions. So the first step is to find AY and BY. To find AY and BY, we apply equilibrium relations. Okay, So first, the first relation I can write is that sum of forces along y equals to 0. What do I have? I have minus ay plus by. And for my distributed load, I have a downward force, and the force is equal to the area of the rectangle, which is 4 times 2, which is 8. Okay, so minus ay plus by is equal to 8. Okay, this is my first relation. My second relation, to find the ay, I can do sum of moments about b. So if I do sum of moments about b equals to 0, what do I get? I have about b, first I will choose a positive direction. Let us say I choose counterclockwise as positive. Then I have that ay has a positive moment, and the distributed load has a negative moment. Now for the distributed load, I can replace it by one force passing at the centroid of the rectangle. So the force is equal to 2 times 4, equal to 8, and it is at a distance of 1 meter from B. So this distance here is 1 meter. Okay, and now I can do sum of moments. I can say that I have plus ay times 4, so 4 times ay minus 8 times 1 is equal to 0. So I deduce, so ay is 2. Okay, it's 2, and as predicted, I got a positive result because ay is downward. Once I get the value of ay, I can replace back into my sum of forces along y equation. So I get that by is equal to 8 plus ay equals to 10 kilonewton. Okay, now always verify your reactions, because if your reactions are wrong, the whole numbers for the problem will be wrong. This is why how you can verify, for example, your reactions. You can try to do sum of moments about A to see if you will get 0. Okay, if by is not if you have a calculation error for by, you will not get sum of moments about A equals 0. So let us try it for verification. If we do sum of moments about A, what do we get? Let us choose the counterclockwise as positive. So choosing the counterclockwise as positive, we have the moment of by about A is in the counterclockwise direction. So I do plus 10 times the distance, which is 4. So it is plus 40 for by. Now, which is 4 times 10. Now for my distributed load, as usual, I replace it by a force, which is here. We already found the force, it's 8, and passing by the middle. So here I have 8, and the distance already we have seen together that this distance to this point is 1. But since I'm doing sum of moments about A, I need the whole distance, which is 1 plus 4 equals to 5. So the whole distance is 5 meters. And now I can say that I have a negative moment for my distributed load, and it is minus 8 times 5. So if you do here minus 8 times 5, you get 40 minus 40. It's 40 minus 40 equals to 0. So it is verified, and my calculation is true. Okay, now once I have my external reaction, I can draw the shear and bending diagram. So we can continue this problem next time. We will draw for this beam how the shear and bending moment are varying. If you give me, can you give me just 1 minute more, or do you have another class?
I have the class at 9.
Okay, so we continue next time. Bye bye.
Thank you, doctor.
Welcome.
Doctor,